Here's another one about forces. Pair of point charges, Q and Q prime. Q prime is negative, by the way. Q is positive. So Q is this one up here on the y-axis. Are moving as shown in the figures with two different speeds. Charges, or two different velocities at least. When the charges are in this position, what's the direction of the force by Q prime on Q? Magnetic force, I should say. I didn't write it, but I'll say it out loud. Magnetic force, not electrostatic force, but the magnetic force of one on the other. Got about 15 seconds left. It's another two-step one. Figure out the direction of the magnetic field, then figure out the direction of the force. So how does Q prime exert a force on Q? Well, Q prime produces a magnetic field. So Q will feel the magnetic field that Q prime produces, if there is one, and if Q is moving, and it is. So Q prime is moving up the screen, but it's negatively charged. So that's like a current moving down the screen. A current moving down the screen by right-hand rule, thumb pointing down the screen. The magnetic field circles around so that it's into the screen when you're over here on the left, and out of the screen when you're over here on the right. This negative charge moving upward is like a positive charge moving downward. It's like a current moving down. It is a current moving downward. And a current moving downwards gives you a field that's into the screen on the left, to the right when you're behind that charge, out of the screen when you're over here on the right, and then the magnetic field points to the left when you're in front of that charge. So that's the way it circles around the charge. So when you're over here on the left, the magnetic field points into the screen. So this positive charge here, moving to the right, feels that magnetic field that points into the screen, a magnetic field pointing into the screen, so get out my right hand, should give me a force that is C up the screen, which is certainly the winner here, but not a dominating answer. Again, two things you have to do, both of them. Actually, it's kind of three things. You have two right-hand rules, and then you got to remember that it's a negative charge, and so the current is downward. So again, a lot of stuff to be juggling around while you're trying to straighten out the direction of this. I'm pretty sure that the force is up the screen. Any questions about that? Yeah.
So I'm kind of confused on like having a charge Q prime exerting the force on Q. Like I feel like so we're doing the right hand rule on, or the second right hand rule with the engineering positive Q going right, correct?
Right, where there's a magnetic field into the screen.
So would it that charge Q be exerting a force onto Q prime, not Q prime exerting a force onto Q?
Well, each of those things have to happen. They both happen. What I asked you was the force by Q prime on Q. And the reason Q, so this is a force that Q feels. A force on Q is a force that Q feels. So the reason Q feels a force is because there's a magnetic field there. The reason it feels a magnetic force. So that's kind of the big field picture is exactly that way for both electric fields and magnetic fields. A charge feels a force if it feels, in feeling a force, it is feeling the field at its location. If there was an electric field at this location of this plus charge pointing in the positive y direction, no matter what caused that electric field in the positive y direction, then that positive charge would feel an electric force upward. So it depends on the field that that particular charge feels. And I haven't said this for quite a while, but that's what our field model is. One set of charges, one charge or one set of charges produces a field. We try to figure out the total field due to those charges. It might be a magnetic field if they're moving, if there's currents. It might be an electric field if they're not moving or even if they are. And then some other set of charges feels the field that we calculated for the first one. So that's the kind of common rule that we're going to use over and over again when talking about forces. If we only talk about fields, then we only have to worry about the production of the field and adding them all up. But if we're talking about forces, we need to worry about the production of the field and the feeling of the field in terms of the force that you calculate. Any other questions about that? I'll let you work that one out if you, well, it's a homework problem.